So let us come to, applications. This is the forest cover map of the India prepared by the group of scientists, as I mentioned earlier. This is the forest cover map of the latest report SFR of 2019. See the degree of variation. See the fineness in cartographic representation. It is all technology is changing. Computers have come, better algorithms have come, and people are able to extract information in much more effective and efficient manner. This was more of a visual interpretation, which was done over the glass table. This is based on computer processing. People call it visual image processing, digital image processing. So that way technology changes. And how do you do it? You have a data set wherein you see the degree of redness, that all is forest. This is very close to you, Sonitpur. You might be knowing this, that in this time frame, a lot of forests got degraded or deforestation. So it was all red in 1994. In 1999, it was relatively gone. In 2000, it was jet. It has a story. We had a researchers working way back in late 90s. So a group of co-researchers, they went to for field work to Arunachal Pradesh. And when they went in 1999, they got to see some kind of forest and all. And the next year, when they again revisited that area, they got to see, oh my God, entire forest has been cleared. And they got confused. Last year we came here, it was having some tree cover, but now not. Thankfully, they had GPS, they were having coordinates and field photographs. When they came back to institute, they tried looking at their earlier document, and they got to understand that, oh my God, it was all forest in 1999, and in 2000, it is all cleared. People were not knowing that. Then they looked at the historical data set and tried mapping it, and then they reported it that deforestation is taking place in the somewhere Sonitpur district, and which is bordering Arunachal Pradesh and Assam. And believe me, in that year, it was rated at the highest rate of deforestation in the entire world. This has come as a feature in National Geographic also. If you follow those magazines and all, you might get hold of that. This was the highest rate of deforestation. And this was not that they planned doing it. They went to same area in 1999, and for the research, they revisited same area in 2000. But they were vigilant. They were having documented evidences using GPS, field photographs, and they could see the satellite data. And then they discovered such kind of changes. Many a times these changes are these kind of clear felling. This could be for road construction, maybe some illegal cultivations. So any kind of geometry typology which is happening on the ground, whether geometric, corridor, fishbone, diffuse, patchy, island, those should be seen on satellite data. See this. This is a data of 1975, and this is a data of 2010. Same location. See the degree of redness which has gone. So this kind of changes one should be able to see. Not only this, for some of this is Nokrek biosphere. No, this is from Odisha. So such kind of changes could be seen in other locations also. There could be reasons that deforestation is taking place. So typically what people do, they take satellite data, they try taking the seasonal data, carry out some kind of geometric and radiometric correction. Fortunately, you are getting most of the data sets from Lancet free of cost, and also Sentinel. Many a times geometric and radiometric corrections are done. You do a degree of enhancement, playing with data so that you can see it much more clearly. It could be linear stretching, it could be ratioing, and then you do on-screen digitization. But remember, ground truthing is must. Without ground truthing is something, it's wrong. You also use ancillary data set, further do ground checking and make a map. Same area for time 2, you just need those vectors and put on the satellite data of time 2, carry out similar kind of analysis. But while interpreting, you just need to modify the boundaries, so that if change is 10%, your work is only 10%. If change is 2%, your work is only 2%. See this. This all was forested here. This all has got cleared. So you can just change the polygon. This was all forest here in 1991. This all 1996 non-forest. So such kind of things people do. And why these things are visible? I hope you all have gone to forest areas. You have seen canopy density, like you do stand density, bole density and all. So canopy density looks like this. Same thing when from space somebody is looking or your satellite is looking, they are also able to appreciate this openness. And that comes in different density classes. So people make different density classes, 80% plus, 60 to 80, 40 to 60. Like I said, in Forest Survey of India, you have 4 density classes. In FAO, you have more density classes. This all depends. What is your scale of mapping and what is your objective? So those kind of things are generally done. You can also play with these bands, as I said, near infrared. I just showed you one standard false color composite. I can change the bands, and the information which was not very evident over here, this has come much more evident. See this 432, 434. I'm just using 2 bands here. Here I am using 3 bands. Near infrared, red and green. Here I am using near infrared, red and near infrared. And I am able to see something different. So it is more of a, reasoning and then playing with data so that you are able to see something better, new, which is otherwise not visible. And this is how my satellite data looks like. If my density is more than 80%, it will appear all jet red. If my density is very less, all redness will go, only cyan color will be appearing. And this is what people do. So as visual interpretation was being done, when computers came, people started doing such kind of processing with computers. And as people were able to understand data set in much better way, they created their own set of algorithms or own set of, what we call it, indices to play with. And there is a model called forest canopy density model, which was developed by a group of scientists from Japan and India. And then you are able to develop such kind of density classes. And, like if you see a good photograph, you say, wow, it is beautiful. Same way, when you see a map, you don't call it is beautiful. You ask, what is the accuracy of that map? A map without accuracy, even 100% correct, is useless. A map without accuracy, 0% correct, is equally useless. But a map with 80% accuracy, but reported accuracy, 60% accuracy with reported accuracy is good. What is accuracy? You compare your map with ground, and then you say how correctly I have represented ground on the map. So here you have 91% accuracy. Here you have 81% accuracy. Here you have 87. See, visual, though it is very controlled, you have 87% accuracy. See this FCD mapper, where you are using different indices, computers and all, 91% accuracy. So it all depends, how nicely you are processing, analyzing your data, and you might get much better accuracies. As I showed you for forest cover, people also do for forest type. So this was in one of the project activity, and this module was developed wherein you take seasonal data and you do a ground truthing. While doing ground truthing, you try to monitor which are the dominant species. Then only you will be able to say what type of forest is there. Type is always defined by the seasonal variant there and the dominant species. So you need ground truthing of this order. And then you can prepare forest type maps like this, wherein you can explain phenological types. You can explain other land cover classes. So why do you need this? If you can do it on the temporal scale, like say, I have a map of 1990, 99, 2009, 2014, I should be able to see what kind of changes have taken place. As this is one of the complicated landscapes, Himalayas, Kumaon Himalayas, I believe. So that kind of, mapping could be done. See the degree of details. It is not only talking about types, deciduous, it is saying deciduous dense, deciduous open, pine, pine dense, pine open, oak, oak dense, oak open. So mixed open, mixed dense, plantations, scrub. So such kind of details could be churned out from the satellite data. The spatial resolution is around 30 meters. You can do it for toughest terrains in the countries like Arunachal Pradesh, entire Northeast India for that matter. So this was generated in one of the research projects, DOS-DBT, which is named, and wherein such a detailed kind of, classification was done. As scientists who are doing such kind of things in different institutes and all, Forest Survey of India also thought, why can't we prepare forest type map? Since 1987, they were making forest cover map, density classes. In 2010, they thought, let us make forest type map. And they used champion and state information and very intensive ground truthing. And this 14-step methodology, and they prepared the forest type map. And now they want to do it, if I am correct, after every 10 years, because type doesn't change very frequently. It is density which changes. So such kind of maps are there. See this is another set of scientists. They have, around 21 institutions. They tried making such type of information, and which is being used. And if you see this plantation, eucalyptus plantation, acacia plantation, cassarina plantation, endless plantation, mixed plantation, name the mixed formations, gregarious formations, those all are mapped in this. So that is how, forest type mapping or forest understanding is becoming better.